All right, let's keep moving through this. We're going to move on. This is lecture 19, part B, and we're going to pick up where we left off in part A. So let's go ahead and get started. All right, so let's review kind of the important things from part A of this lecture real quick, and then we'll get on to how this relates to electrons. So in part A, we talked about how when you look at a light bulb is going to give you every single color of the rainbow. Light bulbs produce every single color of the rainbow. What was that called when you see every color of the rainbow? All right, now if you look at an elements, if you add electricity to them, just like you can to a light bulb, now they're going to give off light as well, but they're not going to give off every single color of light. So elements only produce certain colors of light. So when you only see certain colors of light, what do you call that? Okay, so this is sort of like what we would see, right? So a light bulb gives off every color. That's called a continuous spectrum. Elements, when they glow, they only give off a few colors of light. Now, the other thing I want to remind you about light, besides that we're only going to get certain colors from elements, is that different colors of light correspond to different amounts of energy. So that's what this chart was showing us, right? So violet light is the highest kind of light, highest energy kind of light, and red light is the lowest energy kind of light. All right, so different colors of light correspond to different amounts of energy. So the reason we see colors of light coming from these elements, well, a guy by the name of Niels Bohr figured this out, why that is happening. And he figured out that it really has something to do with electrons and the way they're arranged in an atom. So he said, well, I know in an atom, there's the nucleus, right? That's where your protons and your neutrons are. And he said, well, you know what's going on outside of the nucleus? There's going to be these areas where electrons can exist. And electrons are going to circle the nucleus in a specific orbits. So kind of like how planets circle the sun. So there's an inner orbit. There's a little further away orbit, or you could say ring, and there's another further away one. So there's these orbits where electrons can be found. Now, instead of calling them orbits, he called them shells. So he said electrons circle the nucleus in specific orbits that he called shells. Now, in fact, he even numbered them. The closest in shell is shell 1, and then you go to shell 2 and shell 3. All right, now, as far as that goes, there are more shells than this. I'm just kind of showing you for right now, like the first 3 shells. All right, they keep going 4, 5, 6, and so on. So what he said was going on is that when you add electricity or light to an atom, it causes electrons to jump from the close-in shells to the further away shells. So electrons actually like to be kind of close to the nucleus. But when you give them energy, energy will make them go from a close-in shell, for example, shell 1, to a further away shell. So when we add energy, so that energy again could be like heating up an element or adding electricity to an element. Now, electrons don't necessarily want to be in these further away shells. So we forced them to go far away by giving them energy. And when they absorb that energy, they get moved further away from the nucleus. So they go on a little trip. Now, just like you maybe, when you go on a trip, it's kind of fun for a while, but eventually you want to go back home. Same thing for the electron. It would really rather be closer to the nucleus. So electrons will return to their original close to the nucleus shell. And the way they do that, they release, or you could say emit, they release light. And they release light. So if energy takes them further away from the nucleus, when they want to go back home, they've got to lose energy. And the way they lose energy is they give off light. So an electron going back closer to the nucleus, they give off light. All right, So it turns out the color of light we see depends on how much energy they're losing. All right. So you add energy to an electron, it goes far away from the nucleus. When it wants to go back home, it's got to lose energy, and it loses energy in the form of light. Now, there's a few more terms I want to remind you of. All right, so those terms are, well, or tell you, I guess you haven't heard about them yet. All right, so when electricity, let's go to step 2 here. When electricity or heat is added to an atom, it causes electrons to jump from a close to the nucleus shell. A close to the nucleus shell, that's called a ground state. A ground state. So a shell that's close to the nucleus is called a ground state. The electron will move to a shell further away from the nucleus. A shell further away from the nucleus, that's called an excited state. An excited state. All right, one more term. When electrons, that should say want, I wrote the wrong word there. When electrons want to return to their original, close to the nucleus shell, they release light. And the way they release light, we'll say, is they release light in the form of a photon. So what's a photon? A photon is just a piece of light. A piece of light. Okay. All right, so they release light in the form of a photon. All right, so with that, let's see if I want to give you a little more detail about one element, and that element is hydrogen. All right, so let me flip over and I'm going to show you one more diagram related to this. Let's get to the next slide. Okay, so Mr. Bohr, I don't know, close to 100 years ago, figured out that when we see light coming from elements, that has to do with electrons moving between these shells. Now, he actually figured out a little bit more than that. He could prove, and I'm not going to get into how, but basically by doing some math, that when we saw hydrogen, you might remember I mentioned hydrogen gives off 3 colors of light. It gives off red light, it gives off kind of a teal, bluish green, and like violet light. And he figured out that those corresponded to an electron falling between different shells. So when an electron has to give off just a little bit of energy, it's going to give off low energy light. So let me ask you a question real quick. What color light is low energy light? Is it red or violet? Which one is low energy? It's red light. So red light is a low energy color. So when an electron goes from, it turns out, from shell 3 to 2, when it falls from shell 3 to 2, it gives off red light, which is low energy light. Now, if an electron falls a further distance, let's say, for example, from shell 5 back down to 2, if it goes from 5 to 2, it's going to give off higher energy light. And higher energy light would be like violet light. So if you have a little energy to lose, shell 3 to shell 2, you give off red light, low energy light. But if you got a lot of energy to lose, shell 5 to shell 2, you give off high energy light, which is like violet light. And the bluish green, that's sort of in the middle. That's an electron going from shell 4 to 2. So different, moving between different shells corresponds to different colors. So there's 3 of them. All right, so with that, that's how hydrogen works. The other elements, similar idea, I suppose, a little different. Okay, so with that, that's basically what allows us to understand or to know that these regions, these shells exist. The fact that understanding that exist, it's explaining that where light is coming from. So that's kind of the proof that they exist, that light we can understand what's forming light because of these shells. Okay, with that, let's do a couple more last practice questions here. Let's flip over and we'll do our practice questions. All right, first one. Light is emitted from an atom when, which one of these sounds right? Light is emitted from an atom when, good, all right. One more. Oh, there's a lot of terms right now. Let's see if you remember one of the terms I talked about in this video. Okay, hopefully this is making sense. If not, you can email me, you can call me, whatever. So we're going to move on. There's going to be one more video. And so now we sort of know, hey man, there's these shells where electrons exist. We're going to learn a little bit more about these shells. So that'll be in part C of this lecture. Let's get to it in a minute.